What's up, skillets? Let's go ahead and do problem number 6. 6B to be precise. Notice you're not given any information here, so hopefully we can factor this using factoring techniques. Let's look at the first set of parentheses first. And it's kind of gross looking. Let's look at it like this. Let's look at it as negative 2x cubed plus 8x. Sometimes rearranging a term will make our mind understand what's going on there a little bit more easily. Now, let's see what we can pull out of both of these terms. Since my leading coefficient is negative, I want to pull that negative out to make it less gross. So I pull out not only a negative 2, as I just wrote, but also an x. And what am I left behind with? Well, negative 2x times x squared is x cubed. Is negative 2x cubed. And if I factor a negative 2x out of 8x, what's left behind? Minus 4. How do I know that is correct? I know that is correct because negative 4 times negative 2 is 8, giving me my coefficient, and times x is giving me 8x. So I'm happy, and I'm about to be even happier because I recognize that this is a difference of squares, which will factor as x minus 2, x plus 2. Sweet. Now let's go down to this quadratic. How do we factor this little amigo? Well, we say what are two numbers that multiply to 2 and add to give you negative 3? How about negative 2 and negative 1? Does that work? Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. So I'm really happy. And I can copy this down. Copy to show all my work. And we get here and we're like, sweet, we're finished. Y equals that. And then you graph it and you're sad because you make a mistake. Because you failed to recognize that we have not one, but two factors of x minus 2. Which means we should write that as x minus 2 quantity squared times x plus 2 times x minus 1. Now looking at this, we can see we have 1, 2, 3, 4, 5 powers of x, so this is a degree 5 function. Our leading coefficient is negative, which means our end behavior will act like a negative odd powered function, like negative x cubed, or even negative x, which means we're up to the left and down to the right. What about zeros? Well, my x-intercepts will occur when x is, don't forget about that guy right there, 0, and that one, 2, and that one, negative 2, and the last one, positive 1. Now, which 0 do we need to be careful with? That 0 right there, positive 2, because that has a multiplicity of 2, which means that will bounce. Everything else will cross, that one will bounce. Well, what about my y-intercept? Well, maybe you're like, hey, I remember from that last video, that's not an ant sign. That's not either. Tanner, what did you do to me? Maybe, boom, there we go, at. Maybe our y-intercept is at negative 2 squared, which is 4, times 2, which is 8, times negative 1, which is negative 8. Oh, wait, but then we have that right there, which is 0, which is forcing my y-intercept to be at 0, 0, because you plug in 0 and everything's 0. So sadness, or happiness, if you noticed that in the beginning. Well, whatever, let's sketch it. Boom, 0's at 1, 2, 1, 2. Negative 2 crosses. Positive 2 bounces. And we have one at 0, and we have one at 1. I said those backwards, but there you go, marked them all. End behavior is up, down. Which one am I crossing at? I'm crossing at all of them except for positive 2. And I know I'm ending down here, so hopefully when I get there it works out. And I know I'm starting up here, so I'm going to come down, cross, 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 bounce. And I'm ending down just like I thought I should, which is sweet. And it qualitatively looks like that. Why did I say qualitatively? Because we don't have a scale on our y-axis. So that's the general shape of it. But these curves are probably a little more extreme than I have shown. But that is the general shape of this graph, and I am generally happy.